All right, number one here is have a 0.0026 kilogram block is in a bowl whose lip is 2 meters above. This is our value for H. At the top it has a downward velocity. We don't know what that is. And it slides without friction, so conservative forces only, down the slope side. At the bottom it has a velocity of 12 meters per second. What is the block's velocity at the top of the bowl? Okay, so at the top it has both kinetic energy plus potential energy. Kinetic energy because it has some velocity, we're told, and then potential energy because it has some height. But at the bottom where H is equal to 0, it has no potential energy, so it only has kinetic energy. So what we're doing here is we're saying the kinetic energy plus the potential energy at the top is equal to the kinetic energy at the bottom. So that's 1/2 mv squared, that's v top, plus mgh is equal to 1/2 mv bottom squared. Notice that our masses all cancel because they're in every term I can divide through. And then I'm solving for v top. So v top is equal to 1/2 v bottom squared minus gh. Multiply that by 2. And then I'm taking the square root of that. So taking the square root of that entire thing. So that is going to be a half of 12 squared. That is 72 minus 10 times 2. That's 20 times 2 square root. That's the 54, or excuse me, 72 is 52. The square root of 104. And that's equal to 10.2, or just giving 2 sig figs, 10 meters per second. Number 3 is a very similar problem. What is its velocity at point C? However, I have it at rest up here. So that means V is equal to 0. That means the kinetic energy is equal to 0 too. So it only has potential energy at the top. So the potential energy at the top is equal to the kinetic energy at the bottom because it's at H equal, excuse me, I'm looking for at point C, so right here. So it has kinetic energy. It's going to be moving at point C. It's just not going to be moving as fast as, say, at point B, but it also has potential energy. And I want to know what is that velocity. So I say mgh top is equal to 1/2 mvc squared plus mghc, and this is hc right here. In fact, I'll call this HA. So HA is equal to 5. And I'm solving for this variable. So that's going to be mg. Let's go ahead and cancel out our masses. So I'll just get rid of these masses here, here, and here. I divide through. And let's see, solving for VC, I have GHA minus GHC. Multiply that times 2 to get rid of the half, and then I square root that whole thing. And so that's going to be 1050 minus 20, that's 30, times 2, the square root of 60. Is equal to 7.75. 7.75, that's equal to VC, meters per second. So B is the right answer for 3. Cardboard box of unknown mass sliding upon a horizontal frictionless surface has a velocity of 6 meters per second and encounters friction, slides for 2 meters, and then the box has a velocity of 4 meters per second. So I know that this box, which is traveling along, has a big speed here, travels along, and then over here it has a smaller speed because it lost some amount of work due to the frictional force, and the work done by that frictional force is the force times displacement. I know that the work done by that frictional force is negative because really I have an FD cosine theta here, and this theta is equal to 180 because the frictional force is in this direction and the displacement is in that direction. So that's why my frictional force does a negative work. So whatever kinetic energy it had at point A, I take away that amount of work force times displacement, and that's going to tell me how much kinetic energy it has at point B. Okay, I start with kinetic energy at A, I take away the work of friction, and then that leaves me with the kinetic energy at B. So I'm looking for the coefficient. I'm looking for the coefficient of friction. Um, let's go ahead and simplify some, or put in some variables here. 1/2 mva squared minus the frictional force is mu times the normal force. But in this case, because it's horizontal, the normal force is equal to the weight, m times g, times d is equal to 1/2 mv b squared. Notice my masses all cancel. They all go away. I know everything here except for mu, so I'm going to solve for mu. It's going to be 1/2 VA squared minus 1/2 VB squared divided by G times D. Or, yeah, let's just leave it like that. And that's going to equal to mu. You might want to, expand out that algebra a little bit, but in short, I moved this over to the right-hand side, adding it to both sides. I moved this over to the left-hand side, and then I divided through by G times D in order to get the value for mu. So VA is 6, VB is 4. So I have 1/2 of 6 squared minus 1/2 of 4 squared divided by 10, that's my value for G, times the distance, which is 2 meters. 36, 18, that's 18 minus 8 divided by 20, that's 10 over 20, which is 0.5. I don't know if that's right. Let's see, 4 is, yeah, no, 4 is E. That is right. Okay, good. That's the answer then. Girl throws a ball straight up into the air. That was a tough first page, right? Tough first page, but they get a little easier from here. Girl throws a ball straight up into the air and it reaches the height of 10 meters. What will be the speed of the ball when she catches it? So she throws it up, goes up 10 meters, comes back down, and I want to know the speed right here. But the speed right here is the same as the speed right here, so I'm really just finding what speed does she throw it up with. I know that at the bottom it only has kinetic energy. At the top it only has potential energy. I know that those are equal because only conservative forces are acting. So kinetic energy at the bottom is equal to the potential energy at the top. That's 1/2 mv squared equals mgh. Masses cancel. I'm looking for v. V is equal to the square root of 2gh. That's 2 times 10 times 10, square root of 200. Is 14 meters per second. So 5 is A. 6 toy car follow 2 paths shown here. They both come to an increase of height of 20 centimeters, but on path B it follows this curvy path. I want to know what is the final speed of the car for the alternate path. That's path B. Let's see, I'll change this to path B. I had different words there before. Because friction is negligible, the only forces here at work are conservative forces. So they conserve energy. That means the amount of energy doesn't change. So regardless of the path, both cars will have a speed of 10 meters per second. So this figure, 3 blocks of mass m slide down different inclined planes. There's no friction. Which has the most energy? Well, at the top, they all have the same potential energy. So at the bottom, they're all going to have the same kinetic energy. So D is the right answer. Which of these represent power? That would be C. This is potential energy. This is work. This is kinetic energy. So they all just have the wrong units, first of all, because power is an energy or work divided by time. Spring requires a 10 Newton force to compress it by 5 meters. What is the spring constant? Well, F is Kx. Actually, there's a negative there, but it's not terribly important here. So if I have a 10 Newton force, it's equal to negative K if my force is plus 10, that means my displacement is minus 5, so it gets rid of that. So K is equal to 2. D is 9. Spring-loaded gun shoots a steel ball. You compress the spring. There's a spring constant. What is the initial speed of the ball? So I have the spring-loaded gun, and then it lets go of the ball. So here I only have elastic potential energy, and here I only have kinetic energy. So I say PES is equal to KE. That's 1/2 KX squared is equal to 1/2 mv squared. Notice my halves can go away. And I'm looking for the speed. That's going to be kx squared over m square root of v. Square root of 250. X is 0.03 divided by the mass, which is 0.02. I get 3.35, or 3.4 is 10E. You drop a ball from a height of 10 meters onto a spring, and the spring compresses by 2 meters. How much does the spring compress if you drop the ball from a height of 20 meters? All right, so MGH, all of that potential energy is being converted into 1/2 kx squared elastic potential energy. So this initially is 10 meters, but then I increase it by a factor of 2. So I'm increasing this value by a factor of 2. So the question is, what do I do to x in order to get the same increase on the right-hand side? And in order to do that, I have to have a root 2 here. The square root of 2 is 1.4. So if it was 2 meters, now it's going to be 2 times 1.4, or 2 times root 2, which is now going to be 2.8 meters. Inclination is probably, for most of you, going to be to put 8, because you say, well, if I double this, then this is going to be quadrupled. But notice that's not the case, that if I doubled x, h would be quadrupled, but that's not what we're doing here. We're doubling h. We had a concept test question that was very similar to that. Here's a series of questions. What is the work done by the man on the block? Work is FD cosine theta. The force is 45 newtons. The distance is 5 meters. And the angle between the force and the displacement is 28 degrees. So straightforward application of our definition of work. I get 198, or 200 joules. D. Number 12 is D. What is the work done by the gravitational force? Well, the y displacement equals 0, so there's 0 work done by the gravitational force. And what is the work done by the frictional force? Well, the work done by the frictional force will be F times D. Oops, I'm going to pause here for just a sec. Okay, the work is force times displacement, and so I need to know what is the frictional force. So the frictional force is equal to mu times the normal force, and I need to know what is the normal force. The normal force is equal to, I said here, the weight minus the y component. So that's going to be the weight minus f sine of 28. So the weight is, what is it, 80 newtons. And the force was 45. So the normal force is 58.9. So I'm just going to call it 59 newtons. That's my normal force. And so my frictional force is, the coefficient is 0.1 times 59. So it's 5.9 newtons. And so this is going to be 5.9 times the displacement, which is, the displacement was 5 meters. I get 29.5 or 30 joules. For number 14 is C. How much work does a smart checkout can do on a can of soup? All right, well, work is force times displacement. That's going to be 6 times 0.5 or 3 joules. Box slides towards you and you stop it. How can you describe the work done on the box? That would be negative work. What is theta? It's the angle between the, well, force and displacement vectors right here. Which of these is the basic unit for work? Basic SI unit. So work is force times displacement. That's kilogram meters per second squared times another meters. So it's kilogram meters squared per second squared. There it is right there. Physical definition for power is energy over time. Okay, now we're getting into collisions. 4 kilogram mass has a momentum of 30 kilogram meters per second, and a 1 kilogram mass has a momentum of negative 20. What if the two objects collide and stick together? What is their final velocity? Well, initially, the two objects have a momentum equal to 30 minus 20. So initially, their momentum is 10 kilogram meters per second. And so their final momentum is also going to be 10 kilogram meters per second. And that's going to equal to the mass. The combined mass is going to be 4 plus 1, because they stick together. And then their final velocity, which is going to be 10 divided by 5, or plus 2 meters per second. So 20 is D. All right, this is a recoil problem. I think this is straight from OpenStax. I have an object. Initially, my momentum equals 0. Then I've thrown that object, and apparently I got shorter in the process. And I go the opposite direction. So this is my 3 kilogram at 10 meters per second. And then this is going to be 60 kilograms at some velocity, and I don't know what that velocity is. But I know that the sum of these has to equal to 0. So that would be 0 equals 60V plus 30. So V is equal to negative 0.5 in order to make that equal to 0. So my answer is going to be D. It's looking for the speed, not the velocity. If I ask for the velocity, I would expect some directional information, but asking for the speed, I do not. All right. With a mass, so 21 was D. With a mass of 11 kilograms, M1 is moving with 2 meters per second to the right. Mass M2 is initially at rest. It's 22 kilograms. V equals 0. They bounce off, and M1, the 11 kilogram, travels at, oh, I guess I had this wrong. Let's see, so this goes over here. It travels with 1 meter per second, and I want to know the 22, what's its velocity? Presumably it's going to be going in this direction. So, the initial momentum is 11 times 2. The final momentum is 11 times negative 1 plus 22 times V. So that's 22 plus 11 equals 22V. 33 over 22 is equal to V, and that's equal to 1.5, 3 halves, or positive 1.5. Or what is the final speed here? Very similar problem, except I just give you the figure, so it might find out a little easier. So my initial momentum is 1 times 2 plus 2 times negative 1. This is negative. And it's equal to 1 times negative 1 plus 2 times V2F. All right, so that's 2 minus 2. Oh, this is 0. Is equal to negative 1 plus 2 V2F. So V2F is equal to positive 1/2 meters per second. So D is the right answer for 23. Almost done. How long should a force? I'm looking for delta T. I have F. There's my mass, and my delta V my delta V right there. So know that F is equal to delta P over delta T. If I'm looking for the time, I say delta T is equal to delta P over F. These are all vector quantities. So delta T is equal to the mass. That's 25 times my delta V. That's 30 minus 20 divided by the force. That's 100 newtons. 250 over 100. 2.5 seconds. 24 then is D. What is the impulse? Impulse is a change in momentum for a 2 kilogram mass that goes from -4 to 3 meters per second. So delta P is equal to m delta V is equal to mvf minus vi. So it's going to be 2 times 3 minus -4. 2 times 7 is 14. You have a particle of mass m and double its momentum. If the mass is staying the same, it's a particle of mass m. That means I've doubled the speed if I double its momentum. And since kinetic energy is 1/2 mv squared, if I double this, I quadruple the kinetic energy. Rubber mat will decrease the force of impact if an object falls onto it. Why? Because I've increased the time of collision. So when you have a rubber mat like that and you have something that falls onto it, this slows it down until it stops, which causes your F delta P over delta T. It increases this, which causes the force of impact to decrease. That's why it feels softer. All right, delta P over delta T, what is that equal to? That's equal to our force. It's not acceleration, it's not impulse. Impulse would be delta P. It's not momentum, that would be m times v. And it's not acceleration, though it's close. This is actually the mass. This is the mass times the acceleration. So B is the right answer. All right, so that's 28. There's your answers. Notice that 1, 2, 3, 4, 5, 6, 7, 8 questions were straight from Tutor. A number of them, or most of them, were similar to ones that we had, except for some of the conceptual stuff. It might change a little bit, the test. I might change 1 or 2 questions.